So we're dealing with direct and inverse proportion, right? What I said last week, I said the top values are linked to the bottom values by a formula, right? They gave us the formula here. They said the incomplete table below shows one pair of values for A and R, where A is directly proportional to the square of R. So this statement here basically gives me my formula. So I'm just going to highlight it, right? So we have A is directly proportional to the square of R, right? The square, yeah. Right. The square of R. Somebody now coming in. Morning, Delia. Right. So they want us to firstly express in terms of R and a constant K, express A in terms of R and a constant K. That is the first.
Sir, I'm looking at the screen.
Anybody else not seen my screen?
I seen it.
You will have to leave and come back, Selena. You would have to leave and come back. All right? Right. So we want to actually write out the formula. That statement that I highlighted from all the questions we did last week, what you can do, let's go back to the video. You see, we did a whole set of these questions last week, right? It's just the statement gives us the formula. What this formula would be, it would be, let's say, guys, somebody else trying to come in here. All right. So my formula would be A is directly proportional to the square of R. The square of R means we are taking a constant K and multiplying it by the square of R. Anybody got this to their formula? Just one person got it? You didn't get it? Say a formula, you wasn't sure what to do. You get it?
I didn't do this.
This one. Oh, so everybody, Gil was not alone, boy. Anybody online got this formula? I think this terminology, so there was no question we did above that used this wording. That was the problem. Look, I see Jaden Manuel got it, right? So there was no question we did above that actually used this terminology here. So when I say express A in terms of K, it just means I want A is equal to, well, in terms of R and a constant K, it means your answer must have K and the R and the constant K in it, right?
So I'm still not seeing the screen.
You think you've seen it? I ain't hear what you say now. Okay, everyone. So A is equal to something that involves K and R. Basically, that's what they're asking. Okay? Everybody good there? Right. This is the formula we're using to link each column here. We don't know what is here. We don't know what is here. Question mark, question mark. Cool? So we're going to work now. For the first column, what's the value of A for the first column? What's the value of R for the second column? Everybody good? Everybody seen that? So the hardest thing was to figure out what the formula was, right? Let me just scroll up. I just want to link it to what we did last week, right? Now remember this question, I was telling you CSEC was generous enough to give you the formula, which is Y is equal to KX squared. How did I get this formula? They did not even use the word proportional like this formula here used, right? But I gave you all a note on that, right? The note is up here where I said direct and inverse variation can be expressed as directly and inversely proportional. They can use proportional. All right, no problem. So they can use the word proportional or they can use the word variation. Everybody good there?
Say it up a little bit, please.
Say that again.
It could.
All right, I just go through one thing and then I'll go down, right, Selena? Okay, so those who weren't here last week and who joined the class today, let's go.
Selena's sticking, she Wi-Fi.
Who Wi-Fi sticking? Yeah, I realize that, Kadim. Yeah. So let's go through the video from last week. I explained all this in detail, right? This is the full note here. I explained all this in detail last week, right? Right, so we're going back now. All right, where's my question? All right, so the first mission, I told you all, I kept saying over and over last week, the first mission when we're doing direct or inverse variation is to find the value of. Everybody remember that? That's mission number 1. You looking like you remember that, bro. Brother man. So let's look at the first column. What's the value of A for the first column? You all just said it. A is equal to 36 and R is equal to. So we're going to substitute these values into the formula that we just wrote down above here. So you're replacing A with 36 and you're replacing R with 3. Everybody good there?
Yeah.
Use your first column to find K. Let's work. So I'm writing over the formula. A is equal to KR squared. Once again, this formula, I got it from this statement. That is how I got this formula. You hear me, Mr. Man? That's how I got that formula from that statement. Okay? So we're going to work. Instead of A, I'm going to put 36 is equal to K. We don't know what K is. And instead of R, what do I put? 3 to the power of? 3 squared is what? Like fling 9 on the side one time. So, very good. This is like K multiplied by 9, which will now become division when you carry it to the left, right? So this is like the basic algebra concepts, right? So I don't like how I write this. I don't like how this looking, and I just want to show this over neatly. Right, so I'm going to write this K better. Just goes there. Now remember, it's 9 we carrying across, right? 36 divided by 9 is what K is. What would K be, my children? And 4. Excellent. Anybody got 4 for K? Anybody got 4? You got 4, sister? Nice. Right, I see Jaden. It's only Jaden and Janae, boy. The 2 J's.
4 and 1 over 3.
Oh, you get 4 and 1 over 3.
I get 4.
36 divided by 9.
Oh.
Yeah. Cindy coming. Cindy start to belt out answers, yes? Cindy don't play now. Right? Everybody good there?
Yeah.
All you understand now? Those who need to make corrections, you all need to write. Right. So, we found K. I can rewrite the formula that I have above here, which is A is equal to KR squared, right? I'm going to rewrite that formula, right, Janae? What are we writing that formula as, Janae? A will be equal to, boom, 4R squared, right? Everybody good here? But man, you had anything? Or you just didn't do it? You?
Oh, no.
Yeah, you just didn't do it. All right. So there we go. We have A. So we're going and we're using this formula now to find the other 2 columns, right? So let me deal with the second column now. Big question mark. So we'll just call here E, right? So the missing values, we'll just call it A and R. Cool? So we're going to put A here and we're going to put R here. Everybody good there?
Yeah.
So let me find A. Second column, A is the unknown. 5 will be what? What is equal to 5? R. Boom. So we don't know A, but we know R. So when R is equal to 5, cool? A will be equal to 4 by, boom. A will be what? 4 multiplied by 25, which is? 100. Boom, bang. Right? Everybody get that? 5 squared is, my brothers and sisters, 5 squared is 5 multiplied by 5. 5 5s are?
25.
So that's why I said 4 multiplied by 25 one time, right? Cool? Second column. Let me belt out the second column because I'll write it right here. Let me just find the other value, right? I'm scrolling up. So for this last column here, so once we're doing direct or inverse variation, we examining the columns, right, guys? Let's remember that. Because somebody messaged me 12 o'clock last night, like they were now doing the homework, and asking me, sir, what's the pattern here? It's not really a pattern, right? We linking the columns. I could show you the tiny people message me. 12 o'clock in the night. I can't remember who it was. I was sleeping. I was like, they didn't message me, no, they called me. Sir, what's going on with this pattern for number 32, boy? I was like, bro. And it was a fella. I don't even remember who it was.
Hey.
Jeremiah. Oh, it was Jeremiah. Right. I said, bro, I sleep in it. But I still explain it to him. You could ask him, like, me tell her. And was a strange number because I don't have his number saved. So let me go. When the last column is A we have, right? A is equal to 196. Was it 196, Jimmy? Right. So we're using the same formula, guys. A will be equal to 4. No, wait, we have A. So it'll be 196. 196 is equal to 4 by R, which is, we don't know R. We're trying to find R. So 4R squared. We don't know R, right? So I should have put that here. So like here, A was equal to question mark. We didn't know A, right? And then for this one here, R was equal to question mark. We don't know R. Cool? So what we can move here first? What's the first thing we move in here? When we carry 4 here, what do we do with it?
Dividing 4.
Is that Daniel? Daniela. You know that like if we have 4 and R squared like this, multiplication is understood here? All right. So once you have a letter and a number like this, multiplication is understood between the number and the letter. Right? So when I say carry the 4 to the left, I'm doing the opposite of the operation. So if I multiply 4 on that side, I divide it when I bring here. We don't put division signs over here, right? We do over. That means divide. So that is 196 divided by 4. This will be equal to R squared remain on the side. It didn't go anywhere, right? So 196 divided by 4. 49, right? But we need to find R. We don't need to find R squared. So the opposite of squared is, so we need to find the square root of the left-hand side. So I'm coming right over here to continue, right? Square root of 49 would be equal to
7.
R, right? 7 would be equal to R. Okay? All they're working. I need answers coming in from online. All they're working. Right? So we found R, we found A. Mission complete. Given that Y is inversely proportional to this, right? Y is inversely proportional to X minus 2. Now, this might look very foreign to you, Danielle. It's Danielle, right? Daniela, right? It might look very foreign to you, but probably, like, if you was here last week, you would have had a little understanding of it. So let's try to go over it because, watch, this is the homework here. There's these things here, and then I'm going to start something new here, which is writing sentences as algebraic expressions and equations, right? This is something totally different to what we were doing. But let's try to go over the video and see if we can at least catch it. Any questions you have, message me, right? Right. When you leave, all right, no problem. So we go in. Y is inversely proportional to this. So that statement gives me the formula, right? Now, inversely proportional is something different. Who did it? Y is inversely proportional to X minus 2 is going to be Y is equal to what? K over
11 minus 2.
Wait. We ain't writing that yet. We got the formula, right? You are way ahead of the class, right? This is the formula, okay? So for those who can't remember, if I say Y is inversely proportional, well, they're using proportional here, but it's basically variation they use most of the times, right? So inversely proportional, inverse directly proportional, and inversely proportional is another way to say inverse and direct variation, right? Remember that. Wait, I'm going to write directly. So it's inversely proportional to X, right? If I said that from last week, we investigated that this would be Y is equal to K over X. K over X. Right? This is what we did last week. Right? So, in this case here, they did not say X, they said X minus 2. You all seen that? So, instead of putting X alone, you put X minus 2. If I said Y is inversely proportional to the square of X, what would I put underneath here? If I said the square of X, what would I put here instead of putting X minus 2? X squared. Very good, right? So if I said Y is inversely proportional to the square of X, you'll simply put X squared here. if I say y is inversely proportional to, say, 2x, what I put in underneath here? Or catching the drift? If I say y is inversely proportional to the square root of x, what I put in underneath here? Square root of x, right? So it's whatever it is directly proportional, well, inversely proportional to, sorry, is what you're putting underneath here. Directly proportional is to multiply, inversely proportional is to divide, right? I didn't want to like run it over, but
So
that
let me
is-
write you. Let me write that in red. Just so.
yeah, above. Everything is above. Everything is above in your notes.
Where's the note, sir? So you can just write the note a little bit
But
on
I
the
write
front,
it
please.
again because writing things over and over is how things that stick in the head, eh? So let me write it. Directly proportional, write it over, implies multiplication, right? Inversely proportional implies division, right? So I'll put 2 examples here. Danny mom really message man to make you be it. Right, so example. If I say y is directly proportional to square of x, right? Written as y is directly proportional to the square of x is x to the second power, right? Remember I told you all last week, this implies variation or proportion, right? This symbol here. We did that last week, right? So this statement gives us the formula y is equal to k multiplied by x squared, right? That's example number 1. Example number 2. If I say y is inversely inversely proportional to, say, 2x, right? This would mean y is inversely proportional to 1 over 2x, right? This is how it's written, but this implies the formula y is equal to k divided by 2x, right? Okay, this symbol means proportional or varies, right? All right, that's a little better. It's like you're doing an infinity sign, but you don't complete the infinity sign. Jail, write it. I want it to stick. Write it, write on the last part. Yeah, bad like that. Pause, right. So back up to the question now. We said y is inversely proportional to x squared. That gave us our formula. If we said directly proportional, it would have been k multiplied by x minus 2. Right, Emmanuel? Don't use no Emmanuel. Was it Emmanuel? Jeremiah. Right? Everybody good there? Y, if it was directly proportional, it would be y is equal to k multiplied by x minus 2. But it is inversely. So let's work with what CXC gave us, right? CXC said x is equal to 11, and then they followed by saying y is equal to 9. And they want you to find the value of y when x is 29. What is mission number 1? To find the value of what? K. Mission number 1 is to find the value of Christian here? All right, I want to make sure you're here now. Right? That's the beauty of face to face now. I could see you here, right? Well, you can't fall asleep, right? There we go. So back to the question, this was what was 33? Question number 33, right? Right. So I write back the formula. Y is equal to K over X minus 2. And then I'm going to say when CXC gave us these values, right? When X is equal to what was? 9. And Y was equal to? And Y is 9. All right. So X was 11. Right. Everybody good here, right? So let's plug in, find the value of K. Right? You know how to substitute, Daniela?
Yeah.
So like instead of putting Y here, Y is 9. So instead of putting Y, I'm going to put 9 equal to, we don't have a value for K. That's what we're trying to find, right? And then instead of putting X, I would put 11. 11 minus 2. 11 minus 2 is what? 9. So it'll be K over 9. We need to find K. What do we do with this 9? We carry it to the side. What's
And
something?
multiply.
Excellent. It's being divided here. So the opposite of division is multiplication, right?
So that will be 36 divided by 9, sir.
Where you get
No,
36
why is there
divided by 9
36?
from
9,
sister?
9, that 81.
9 by 9 is equal to K. That will be 81 is equal to K, right? Okay, we good here. Let me work. Right. So we found the value of K, which means we could now write out our formula with K in it, right? So I'll put therefore is 3 dots, 1, 2, 3. Therefore, Y is equal to what? Instead of K, what do I put? 81 over
29 over minus 2.
is X. That's all. That's right. On the formula. All the real speeding, but that's good. All you know what's going on, right? So I'm going to put the X minus 2 first, right? Everybody good here? So this formula can be used now to link any value of Y to X. Cool? Any value of Y to X. So CXC went on to say, Cindy, your mic on, Cindy.
Sorry, sir.
No problem. Right. So we working. What was the value for, is X they gave us or Y? What they gave us above? X. That's all. So when, I'll scroll back up. When X is equal to, I'm scrolling up, right? 29? Right, look at here. Find the value of Y when X is 29. Cool? Should have a full stop here. Right. So we scroll back down. These questions so amazing, right? So when X is equal to 29, food, Y will be equal to 81 divided by 29 minus 2. What is 29 minus 2? Right? So I'm going to put Y is equal to 81 divided by 27, which will give me what? 3. Boom, bam. Anybody all right? So we want to
So I have a little fair idea with these here, but let me see how it goes.
Okay, let's go. So we want to solve the following equations, right? I think I want to give all a formula on solving algebraic equations, right? So let me write. Hold on. I want to just move HW. I'm going to pause this. So we just want to break down what an algebraic equation is, right? So an algebraic equation is a mathematical statement that shows two expressions are equal. And it usually involves variables, right? Okay? So to solve an algebraic equation means to find the value of the unknown, which is the variable, right? So to solve an algebraic equation means to find the value of the unknown variable. Right? We go stop messaging me now. Are the same parents, you know?
Shooting somewhere.
Oh Lord. Right. So I'm going to give you some general steps, right? That might apply to some of the algebraic equations. So this is like just general steps. To solve a linear
Sir, you spelled unknown wrong.
where? All right, no problem. Right, I've showed you with linear equation here, right? So I just want to, should I give that? So I want to send this down. Right, let me just put what our linear equation is before I write this, right? So this was like the first note, second note. So a linear equation is an equation in which the variables are raised to the power of 1, right? Example, like there's no x to the second power, no x to the third power, nothing so, right? It's only x to the first power, which is just like x, right? Which would be right? So example would be x to the first power, which is just x, right? So we talk more like x, y, z, e, b. All these things are linear expression, well, linear terms. Okay, there's no power, no x to the second power, nothing in these. Yeah, plain x, plain y, plain z, whatever we work with, it's just that without any squared or anything, right? That's squared back, and I'll go start next week. That's when we start to look at quadratics. Right. Now, I have three worksheets for algebra, right? But I'm going to do worksheet 1 and 2. We're going to branch off into our next topic, and then we'll come back to it, because sometimes your brain does need a little rest from algebra. So we'll do worksheet 1 and 2. Then I'll take into do areas and perimeters, volumes, and then come back to the last worksheet. Cool? That's the order. Right. So I just have some general steps here. All right. So the first thing you must do, if needed, right? So if needed, let me put it there. If needed, you simplify both sides, right? Simplify both sides of equal sign, right? Which means expand brackets, combine like terms, combine. Come in. But man, morning, your time, boy, your time. Right? Right. Expand brackets, combine like terms. All right. So number 2, if needed, you will need to get all variables on one side of equal sign. Okay? Moving real fast. I saw students guys do that nowadays.
What's that word? Expand what? Brackets?
Yeah, brackets. Yeah, brackets. Expand brackets, combine like terms, get all variables on one side of the equal sign. Right? So it'll be like you're move terms using addition and subtraction, right? Using addition and subtraction. Okay? So you're getting all variables on one side, and simultaneously you also have to get all numbers. I want to put numbers. Get all numbers on the other side, right? Okay? All variables on one side, all numbers on the next side, right? And then I'm going to use the word isolate. So isolate the variable using multiplication or division, right? So on pause. Right. So basically they want us to solve the equation, meaning they want you to find the value of x. They want us to isolate x. You're getting x is equal to something at the end, or something is equal to x, depending on which side your x is on, right? So let's work with this first one. The first thing that I told you all above to do is either you get rid of the bracket or combine the like terms. Like terms mean x's with x's, y's with y's, z's with z's. Cool? So let me work. The first thing we're going to do is you're going to move these numbers. Well, I said all variables to one side and then all numbers to the next. Right? We cannot interfere with the 7ers yet. You have to move the 12 first. Cool? So watch it. When I carry 12 to this side, I do the opposite of what is going on here. It is plus 12. So the opposite of plus is to subtract. So what's going on here? I'm putting back the 7x here because that didn't go anywhere. Cool? 33 was there, so I put it back what was there first. 33 was on the right. Everybody agrees?
Yeah.
So I put back the people 33 first, right? Then what came here? 12. plus 12 became minus 12. Everybody good there?
Yeah.
So 7x is going to be equal to 7x is going to be 33 minus 12 as well. What else?
21.
21. Then we've been doing this above. We had to take this 7 carry it and do what with it?
Divide.
Divide.
Okay, so why we dividing, Daniela? Remember I told you above that multiplication is understood here. The opposite of multiply is to divide. So x will be simply equal to 21 divided by 7. X is equal to 3, right? Now some points I want you all to note, right? Sometimes students just see like 7, like say we had the 21 on this side, right? Students just go mad and do this somewhere, right? They like to do this, right? Don't do, right? So what your students like to do? Say I had 21x is equal to 7, and they had to bring the 21 here. You know what the minus glitch and do? They just put the 21 on top. But what really is supposed to be going on here? It's supposed to be, right? This is supposed to be x is equal to 7 over 21. Because they see the bigger number on the side, they just put the bigger number on top. Plenty students just do that for me in school. Look, you see. You see what I'm talking about? Right? This 21 is on the left. You're bringing the 21 here, give people 7 on the right. How you can put the people 7 underneath? Right? This is wrong. Right? This is right. Okay? Write it down. That's some don't do's. Should put don't.
What? 7?
Plenty students just make that mistake. So the answer here will be like x is equal to 1 to if it was 21, x is equal to 7. Everybody good there? I'm not doing another question like this. Right? We're moving on. So I should know the next case. The next case here is if you have variables on both sides. Right? Variables on both sides. From the note I just gave you all, it says that we need to get all the variables on one side, all the numbers on the next. So this variable here, which is 3x, coming here. But what is in front of this 3x here? This is minus 3x, right? So minus 3x will become what when it goes there? Plus. Then we need to get all the numbers on one side. This minus 10 will become what when it goes there? Plus 10. Composure is everything earlier. Composure is everything. Okay? So what I need to do here? You need to compose yourself. 2x didn't go anywhere, and 2x remain on the left.
Yeah.
Composure. I bring 3x here, and so what do I put next? Plus
3x.
I put in the equal sign. What remained on the right hand side? I didn't move that. What remained there? 15. Back to people 15. And then what came here now? Plus negative 10 becomes plus 10. All good here?
Yeah.
Proper thing. Somebody else knocking on.
Second one more time, please. Because we're back up.
Okay. So where want to see here?
Yeah.
Doing again. So from the note above, if needed, I said you need to get all the variables on one side. Variables being like the anything with x's, right? You bring everything on one side and you carry the numbers to the next. So I move the 3x to the left and the minus 10 goes to the right. Minus becomes plus, plus becomes minus if needed, right? So let's work out each side individually. So 2x, you have 2 x's, you add 3 x's to how much x's you'll get?
5 x's.
Proper thing, right? 15 plus 10.
25.
Can I add x's to normal numbers? No. Also remember that, huh? Right? Right. Familiar ground here. What are we doing with this 5? Excellent.
Divide.
X will be 25 divided by 5. X will be 5. Boom. X will be equal to 5. There's no way. There's no way to do here. What is the first thing we need to get rid of here? The brackets. We need to get rid of them brackets. How do we multiply into these brackets here?
Yeah,
Say that again.
I can't see your screen.
All right, they might have to leave and come back. Everybody else see the screen?
Yes, sir.
I see if you probably had to log out and come back in.
Yeah, anytime your screen stops showing, it's probably the internet on your side. Right, so there we go. How do we multiply into brackets? You see the number in front this bracket here? It needs to be multiplied by these two terms within. Cool? So this will be, I'm going to put back the 15 minus 4x, put back the equal sign. But we need to get rid of these brackets here. So 2 multiplied by 3x. Now point a note. Note. Right? Because I have to take into consideration, some people see these things for the first time, right? Now 2 cannot be added to 3x. But not possible. I'm going to put not possible. Not possible. Right? We cannot add 2 to 3x, but we can do 2 multiplied by 3x. 2 multiplied by 3x, it does multiply the 2 by the 3, you get 6x. Cool? Right? Possible. If you want to put it so. Possible. So this is possible, but 2 cannot add to 3x. Please write this down. Please write it down. Okay. Real good piece. Right? So 2 multiplied by 3x will give you 6x. Then 2 multiplied by 1 will give me 2. Then you're ruling with what I told you all above. We fling in that 2 on that side. No, we fling in the 6x on this side. So I want to point out something here, right? When we move in the 6x like this, right? This is understood as plus 6x. Once there's no minus sign in front, this is understood as plus 6x. So we move in the 6x here, it will become minus 6x. And then this will be plus 15. Plus 15 will become what when it goes there? Negative 15. Composure is everything, right? What did I not move here? The minus 4x. Everybody good there? So I'm going to put minus 4x. And we just said what is coming to the left? The plus 6x becomes minus 6x. Equals to, let me write that x a little better. Minus 6x is equal to 2 didn't go anywhere. Now you could put plus 2 since it's plus 2, but plus is understood here. Cool, everybody? Yeah. So you don't need to put this plus. Right? Samara, San, Chanela, and Shania. All right. I remember the Shania, but I don't remember the Chanela. Right. So to be 2 and plus 15 will become what?
Negative.
Minus 15. Excellent. Composure. Talk to me. Right? Keyword here, composure. Compose yourself. Watch what the question have. Do the next step. Right? Now, negative 4x minus 6x would be how much x? This is directed numbers. Punch it in on your calculator. Put negative 4 minus 6. And tell me, where your calculator? Time. All right, no problem. So just pass that calculator for her there. Oh, you using phone, all right? What you getting? Yeah, well, negative 10, right? Negative 10 is what you're supposed to get, but I want you all to see it, right? 2 signs are the same. You actually have to add the numbers and you maintain the negative sign, right? You actually maintain the sign from the bigger number, which would be the minus 6. So to be negative 10x is equal to 2 minus 15. Boom, negative 13. Everybody good here?
Yeah.
Right? So you see what procedure is? Procedure is everything, right? So we reach this step where we simply have to carry this negative 10 on this side. And I want you all to understand something too. There's a lot of little intricate things you have to make sure you pay attention to. Watch it, eh? Right. That's what I'm going to talk about here. What is the operation here? And this is multiplication.
Yeah.
So we multiply negative 10 here. So when you carry it here, you have to divide same negative 10. Right? So x will be equal to negative 13 divided by negative 10. Right? Above here, we are dealing with addition and subtraction. That's why I gave these steps, right? I just want to show you all one thing, scrolling up for a little while. That's why I said these things here. Okay, get all variables on one side of the equal sign. right? And we're going to move terms using addition and subtraction. That's like the first thing you did. Addition and subtraction is what we're dealing with. But here now, we're using multiplication and division to isolate the variable. Meaning we don't want no number in front of the variable. So it's multiplication or division we're using below here. So negative 13 divided by negative 10 gives me what? 1 point. Well, 1 and a third?
Yeah.
Or 3 over 10, sorry. We could write it as a mixed number or we could write it as a decimal. So Brittany got 1 and 3/10, right? Or you could put 1.3, I think.
Yeah.
1.3. Anyone you have would be correct. Right? Right, let's go. Online.
Yes,
First
sir.
thing, face to face. First thing we're doing here, we need to get rid of the brackets. So you're multiplying this. I hope nobody think going to multiply 2 by 5x alone. Eh? It's 2 multiplied by 5x and 2 multiplied by 3. Boom. 4 multiplied by?
So I do that.
I know to that people that would do that too. And above here is the 2 terms inside the brackets we need to multiply by, right? So 2 multiplied by 5x will give me?
10.
Boom.
10,
2 multiplied by 3 is? Excellent.
6.
4 multiplied by x is?
4x.
And then 4 multiplied by negative 3 would be negative
12.
12. Right. So I get that part correct. But then I was like, I don't know where to go from this. I was like, no more wait until
Yes, chunk change.
I usually like it.
So what we do is we fling in this 12 here. No, wait. That's the wrong thing. We put in the 4x on this side. Cool? This is plus 4x, right? Remember, we adding and subtracting. So
Negative.
it will be negative 4x. And then this plus 6 coming here.
Negative 6.
Negative 6. So let me compose yourself, right? 10x didn't go anywhere. It was on the left. Let me put back the 10x first. Cool? Then plus 4x became minus 4x. Put back the people equal sign. Right? What was on the right-hand side? What did not move? Negative 12. Excellent. Right? And then plus 6 becomes
Negative 6.
food. We just call this food. Right? 10x, yeah, 10 x's on our table. Your minus 4 x's. How much x's do you remain with? Negative 12 minus 6 directed numbers. Where you get? Minus 18. Boom, bang. Right? All we working on. We're working right now. So I'm going to take this 6, carry to the right, and do what with it? Food. Food. Negative 18 divided by 6. When I punch that in the calculator, a negative divided by a positive will give me a negative. So what will be negative 3?
Negative.
Negative 3. So I'm on pause this. 2 multiplied by p, then 2 multiplied by 5. 2 by p will be what? 2 multiplied by 5 will be 10. Put back the people minus 7. And then this will be equal to? Remember, we're using addition and subtraction at this point. We're not going to no multiplication or division yet, right? So you can actually work out this here. 10 minus 7 would be what? So I put back the people 2p, and I put back the plus 10 minus 7 will be plus 3, right? And this will be equal to 4p. So what I'm going to do at this point, you can do 2 things. You can either bring the 3 to this side and carry the 4p here, or you can actually just carry this 2p here. You all saw that? You can just carry the 2p there. So this is plus 2p. What 2p will become when it goes to that side? Negative, right? So this will be the next step. 3 didn't go anywhere, so I put back the people 3, right? You could put the plus in front here, but it would be understood after this point, right? Once you move what is in front of it. So I just put 3 alone is equal to putting back the 4p plus 2p becomes minus 2p. Cool? 3 would be equal to 4p minus 2p will be how much p? Boom. Then, everybody familiar with the step. Carry the 2 here, and what you do with it? So 2 divided by 2 or 3 over 2 will be equal to p. I don't need to write that any other way. Just leave that just so. Right? You don't need to go to the next step and then put p is equal to 3 over 2. Because 3 over 2 being equal to p is the same as p being equal to 3 over 2. It's the same thing. You leave that just so. Move on to the next question. Right? But write this p a little better. Pause that. Right. So y'all try to write same speed with me so we wouldn't have to wait too long for anybody, right? And y'all right. I rather y'all write it here and we have to wait till we get the recording to write it home because the real time soaking in is what we need right now. Right, so we're going to convert word sentences into algebraic expressions and equations right? That's what we're doing, right? So some points to note. This process helps us, well, helps you turn real life problems into math problems that can be solved. All right? So, we're going to look at some key vocabulary for translations, right? So, key vocabulary for translations. Right? So on one side, we'll put the word. Right? So our word. And on this side, we'll put algebraic meaning. All right, so we go in. Sum. Let's see if anybody know it. What sum is? Plus, addition, right? Addition, which is like plus, right? I put sum, yes? Sum. More than. If I say more than, what do you think I'm talking about? More than is actually addition also. Like if I say X is 5 more than something, right? It means plus, right? Addition also. Difference. What difference means? Excellent. That primary school thing there, no? Subtraction, right? Minus. So if more than is addition, less than would obviously be to minus also, right? Less than will be subtraction. Product. Excellent. Multiplication. Quotient means division, right? Division. Is or equal, well, both of them means equal, right? Right, is the equal sign, okay? Now, if I tell you, when I'm writing these sentences, if I say a number, right? If I say a number, so like take for instance, I say a number is added to 3. We're talking about a variable. They ain't giving you the number. I say a number is added to 3. Write this as an algebraic sentence. It will be x plus 3. Right? Or a number is more than 3. That will be x plus 3. Right? So once I say a number, you know I'm talking about a variable. I'm talking about x or y or whatever you all want to use, right? etc. Yeah, my Jeremiah? Right? If I say twice a number,
Double.
right? You're doubling it. 2 multiplied by whatever number, right? So twice a number would be like 2x or 2y, etc., right? Okay? Half of a number, what I'm talking about, is just a half x, or you divide by 2. So divide good. Half of a number would be, I ain't like that word off there, that's half a number. If anybody missed anything, I could always scroll up for you all to get it, right? It'll be x divided by 2 or a half x, right? Etc. Meaning like if you want to use a different variable, right? If I say a number squared, right? So a number squared would be like x to the second power, y to the second power, etc. Right? Let's remember squared is the power of 2. So there are many others, but we're just going to stick to these core ones by the meanwhile. Right? So let me pause. No, that one more thing on to write. Right? So this is important to note. I gave it above, but I'm giving it again, right? Expression versus equation. Right? So for expression, no equal sign, right? Equation, equal sign. If you want to use the word contains, I should put contains there. I'll just go and put the word contains. Contains no equal sign and then contains an equal sign. I just want to put the word contains. All right, so contains no equal sign and then contains an equal sign, right? I put VS in the middle here. Perfect thing here, right? So I'll just give you all some tips before we jump into it also, right? So we'll just give some student tips. All right. So use one letter to represent unknown. All right. Look for key words to decide operations. Right? And always try to write expression or equation in the same order as the sentence, right? As sentence, right? So however the sentence built it out is how you're going to